In this video, we will learn how to build the KNIME Bayesian classifier. Let's place the CSV reader node and load the same by a computer dataset that we saw in the decision tree example. Let's ensure that the ID column is not loaded into the workspace, otherwise it will also be used to build the classifier, but we do not want that since this is just an identification number. So execute the node and just take a quick look at the data table. We have to predict this outcome by a computer based on 4 different attributes. Let's partition the data set into testing and training, and we know that training data set will be used to build the model, while the test data set will be used to test the model. So let's keep a ratio of 70-30 and click OK and execute the node. So on this output side, we have 2 ports. The first one is the first partition, which has 9 rows and will be used to build the model, and the second one is the test set partition, which has 5 rows and will be used to test our model. So let's use that training data to build a naive Bayesian algorithm classifier using the naive Bayes learner node. Let's configure the node. So the classification column is by computer. Let's not change any other settings and click OK. And when we execute, we have the classifier which has been built. So the output here is just going to be a table which is going to show us the different counts or the different frequencies of different combinations of the independent variables. So that is what it is. It is simply a count, which we saw as conditional probability tables appears as individual rows in this particular case. It's the same thing, shown in a different way. Okay, so let's send our model to the naive Bayes predictor node. In this particular node, we will have a column added to our dataset, which will be the prediction of by a computer. And let us send the test data, those 5 rows, to this model and execute it. Okay, so if we look at the output table which has been generated, we will see that this was the original class label or the outcome, and this is the predicted class label or the outcome. Let's add a scorer node and look at the model's statistics or the model evaluation metrics. So the scorer node is going to compare the actual by a computer against the predicted by a computer. Let's execute it and open the table. Now, if you see down here, it produces a confusion matrix and accuracy statistics. So first of all, let's look at the confusion matrix. So here it is, the actual no's and yeses predicted as no's and yeses. If you want to take a look at them in terms of true positives or true negatives, etc., here it is. Please remember, we have to focus on this row here, which predicts yes, because yes is our class of interest or the positive class. So we will ignore the first row, which is for no, we will just focus on this row, which is related to the positive class. So we have 2 true positives, 1 false positive, 1 true negative, and 1 false negative. And that gives us an accuracy of 60%. So this is a quick way of building a naive Bayesian classification model and testing it on test data. Test data was the one which was not used to build the model. And then finally, using the scorer node, we can get all the model evaluation metrics in terms of precision, recall, accuracy, and also the confusion metrics based on the variable of interest, which was by a computer equal to yes, or the positive class in this particular case. So that will be all about the naive Bayesian classifier using the KNIME analytics platform.